the late 1980s, Roche applied Nobel Prize-winning Polymerase Chain reaction, or PCR technology, to develop the world's first molecular diagnostics that could identify diseases by analyzing DNA or RNA. At that time, the dramatic impact PCR would have on industries outside of healthcare was also unfolding. Today, PCR, a method to copy or amplify small segments of DNA that facilitates the subsequent analysis of genetic material, is used across sciences. In transplant medicine, PCR can identify organ donors that are matched to the recipient. It is used in forensics to provide DNA identification of the source of crime scene evidence to help convict the guilty, or alternatively, to free people who may have been falsely imprisoned or accused. Dr. Henry Ehrlich, one of Roche's original scientists, who helped evolve PCR into the elegant technology it is today, has worked for years with the Innocence Project to help free people falsely accused of crimes based on evidence made possible by PCR technology.
PCR has been enormously valuable not only in forensics, but in missing persons, in war crimes, mass graves. So our lab has been involved in a number of those things, and technology that we've developed has been applied in many of those cases. We still work very closely with the International Coalition for Missing Persons, which is based in Sarajevo, and we've had scientists work in our lab from Croatia that have been involved in mass graves. You can start with a very small amount of material, a single molecule really, but in the forensics community, as we all know, saliva from a cigarette butt or an envelope or a single hair. So all these things are enormously valuable, and in addition to identifying the source of evidence and helping convict the guilty, it's been extremely valuable in demonstrating that some people, innocent people who've been wrongly convicted, have been exonerated using DNA evidence. We actually did the first post-conviction review in which a wrongly convicted person was freed as a result of this test. That was in 1987.
Not only for the court systems and healthcare, PCR has made an impact across sciences, touching on everything from anthropology to veterinary medicine. PCR is the cornerstone for genetic identification and fingerprinting. Uses range from identifying victims of natural disasters and wars, to confirming genetic links between organisms living now and those that have lived thousands to millions of years ago. The National Center for Biotechnological Information states that the application of molecular DNA technologies to anthropological questions has meant that rare or archival samples of human remains, including blood, hair, and bone, can now be used as a source of material for genetic analysis. Even our beloved pets have benefited from its discovery, and PCR is used to determine pedigrees or diagnose disease. Various other uses for PCR include paternity testing and basic DNA research. Without PCR, the human genome would have never been unraveled, and our understanding of fundamental molecular biology would be limited. It is no wonder that PCR technology is called one of the most important scientific discoveries of the 20th century. At Roche, we remain committed to providing the most innovative diagnostic products that make the best and most efficient use of this world-changing technology.